Alright, I want to make a video, it's been a long time coming really, for basically just showing you what's going on with the geometric sum, okay? This is a finite geometric sum. This is called the nth partial sum. You may be wondering, why do I have n minus 1 if this is the nth partial sum? If you recall, the nth partial sum means the sum of the first n terms. Are there n terms here? There are absolutely n terms here. This is r to the 0. How do you find out how many terms are in a finite sum? Or just a finite set in general? You take the highest thing, n minus 1, and subtract 1 minus the lowest one. The lowest one is 0, 1 less is negative 1. N minus 1 minus negative 1. Oh, that's n. Those are n terms. All right. Does it converge if I look at infinite sum, and what does it converge to? Well, first thing you need to know is the following. So I'm going to apply a trick. So then multiply everything by a. Or sorry, multiply everything by r. R Sn equals ar plus ar squared plus ar cubed, keep going, plus ar to the n minus 1 plus ar to the n. Now again, there are still n terms. It looks like there's more, but there are still n. All I do is I took this, multiply everything by r. I get this. Subtract it. Subtract everything. So let's, I have this. Let's subtract everything. On the right-hand side, subtract piecewise. Every single piece, combine like terms. Well, what gets rid of, what's gone? So the right-hand side, these are gone, right? This is gone, 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 this is gone. And this one will be gone with this one, right? So what I'm going to get here on the right-hand side is just a minus ar to the n. What's on the left-hand side? Sn minus r Sn. Let's get Sn by itself, the nth partial sum. All right, just do some algebra, no big deal. This tells me that Sn is equal to, factor a out, a 1 minus r to the n divided by 1 minus r. This is the formula that you need to know. You need to know that. This is the sum of the first n terms for a geometric sum. Only a geometric sum. You absolutely need to know that for exam P, for just life in math. Not life. Because you know math's useless, right? Just kidding. You do need to know this for Calc 2, absolutely. Alright. What is the formula for the infinite sum? So, we need a condition. Notice if the absolute value of r is less than 1. What does that mean? By definition, you'd be familiar with absolute value. This means r is between negative 1 and 1. It's greater than negative 1, less than 1. If I have this condition, then the limit as n tends to infinity of this business, right, of Sn, which is the limit as n tends to infinity of a times 1 minus r to the n over 1 minus r. Think about my assumption. R is between negative 1 and 1. Let's pretend r is a half. If r is a half, and I raise it to a power that's getting larger and larger, I'm thinking 1 half to the 1, 1 half squared, 1 half to the 4th, 1 half to the 5th, 1 over 32, 1 over 64, 1 over 128. It's approaching 0. This is tending to 0. This tends to 0. My sum converges to the first term over 1 minus r. Just as you should know. It's always the first term over 1 minus r. Now, let me continue. You may already know this. One more thing that's useful. What does another related series converge to? Okay, let me show you this little trick. Just involves the derivative, and if you understand what I've done so far, you know what a derivative is. So now I want to know, what does the following series converge to? How about this series? So, find the value of the sum, let's say from n equals 1 to infinity of n r. Let's do it this way. A n r to the n minus 1. So there's a lot of just letters floating around. Okay, this is for r, again, we need the condition, otherwise it doesn't converge, right? So, let's see what we can do. Let's see what we can do. So this is equal to, I'm going to just take the a out, let's get rid of that. This is, take the a out, the sum from n equals 1 to infinity, n r to the n minus 1. This looks like the derivative. Let me do something. This is equal to a times the sum from n equals 1 to infinity. I'm going to write it this way. This right here is the derivative with respect to r of r to the n. Take a step back and think about, is that true? Hell yeah it is. I mean, if my variable is r and I treat n as a natural number, how do I take the derivative? I take the power rule. N comes down, subtract 1 from the exponent. And what I'm about to do is quite technical and careful. I'm bringing the derivative outside the sum. This is an infinite sum. You have to be careful. It has to converge, I think, uniformly. Well, we don't care about that terminology, really, unless you're doing real math, abstract math. But we're not doing that, right? We just want things that work. So I'm going to bring the derivative outside the sum. Okay, this is equal to a times the derivative with respect to r times the sum n equals 1 to infinity of r to the n. And actually, this needs to be, when I look at the derivative here, this needs to start at what? This needs to start at 0. That's true. It is true. Okay, so what do I get now? So now, what is this value? We just found this value. This is a converging geometric sum. So this is equal to a times the derivative with respect to r of, this converges to the first term, which is 1, over 1 minus the common ratio. How nice. This is equal to a times, what's the derivative of this? Derivative of this, use the chain rule, right? Convince yourself you can do it. This is 1 over 1 minus r squared. This is a over 1 minus r squared. Squared's on the outside. This is also an important formula to know. It's an important series of what it converges to regarding the geometric sum. Tell me what you think. I hope it makes sense. You may have to fill in any gaps that didn't make sense, but always comment on the video, request, and thank you for subscribing.